Okay, in numbers 9 through 16, it says find the test statistic or the critical value for the following test statistic or for the following tests. So up here in the top, what I'm going to do is write down your formulas for your test statistic. If we are calculating the test statistic for a mean, whether or not it is z or t, you will calculate it from x bar minus mu divided by the standard deviation over the square root of n. If you are calculating your test statistic for a proportion, then z will come from p hat minus p over the square root of p times q over n. Now, your critical value. For a small sample, which is when n is less than 30, you're going to use the t-distribution. For a large sample, when n is greater than or equal to 30, we use the normal curve or the bell-shaped curve, and in our calculators, we get it from the inverse norm. Okay, so number 9. You wish to test the claim that the mean is greater than 6 at a level of significance of 5% and are given the following sample statistics. Compute the standardized test statistic, round your answer to 2 decimal places. So again, this is a test for a mean. So for a mean, this is the equation that we use. It's a large sample. So we're going to do 6.3 minus 6 divided by 12 over the square root of 50. Now, in your calculators, if you're going to enter this as one calculation, you use parentheses in the numerator, parentheses in the denominator. And we get to 2 decimal places, 0.18. 10. Find the critical value for a two-tailed test. Alpha is 1%, n is equal to 30. N is equal to 30, this is a large sample, greater than or equal to 30. So we have a z-score here for our critical value. Now, it is a two-tailed test. So in a two-tailed test, we do split alpha in half. So we have 0.005 in each tail. So for our inverse norm, we are going to enter in 0.005, and the calculator gives us negative 2.58. But we know that in a two-tailed test, we have both positive and the negative. Number 11, find the critical value for a left-tailed test. And we have that alpha, critical value is z with a little sub-zero there. Our alpha is 0.025. We have a large sample because n is greater than or equal to 30. So we're going to find our critical value from the inverse norm. We get negative 1.96. Number 12. Find the standardized test statistic t for the following sample. Here's our sample statistics. We have a two-tailed test. Round your answer to 3 decimal places. It's 3 decimal places because it's t. But our test statistic comes from the same equation that we use for n is 12. Now, another way that you could enter these into your calculator is if you have that fraction option by hitting alpha and y equals. In the numerator, then we won't need parentheses. The calculator will understand. is the way that we write it on paper. So if you calculate it this way, that's fine. And we get negative 0.82523 decimal places. 13. Find the critical value for a sample where n equals 10. So we have a small sample, and we're finding the critical alternative hypothesis would be less than. So we have a left tail test. Small sample, our critical value is a t-value. We need to know our degrees of freedom, which is n minus 1, so that would be 9. So in our t-distribution, we're going to 1 tail alpha, and we're at 5%, and then our degrees of freedom is 9. We get 1.833 in our table. But we have a left tail test, so we should know to make that critical value negative. Number 14, find the standardized test statistic t. So again, the test statistic comes from our calculation. Into 3 decimal places, we get negative 0.894. 15. Determine the standardized test statistic z to test the claim about the population proportion. So our test statistic comes from p hat minus p over the square root of p times q over n. So p hat is 0.612, minus p is 0.7. Then we need q. Remember, q is going to equal 1 minus p. So q is 0.3. And then n was 50. Okay, to 2 decimal places, we get negative 1.36. 16. Determine the critical value to test the claim about the population proportion. P is greater than or equal to. That would be the null. The alternative, we're really only looking at the alternative to make sure that we have the correct sign for this. So it's a left tail test, so we do want that critical value to be negative. It's a large sample, so it's z, and alpha inside of our tail is 5%. So to find that critical value, we do the inverse norm of 0.05. Now rounding to the nearest hundredth, we're going to get negative 1.64. Technically, if we were using the table, it would be negative 1.645.